Hi, welcome back. Last time we were talking about an intervention of adding an immunization to our simulation and seeing how that changed the percentage of the population that got infected um, during our simulation. And what we saw is that by putting in an immunization of 10% of the population, we were able to reduce the amount of people who were infected from 47% down to 31%. And so that really begs the question, what happens if it were not 10%, but 20%, 30%? How does that change the total number of people who get infected? And so to answer that sort of question, what we're going to do is we're going to set up a parameter sweep where we're going to change this, let this number 0.1 vary over a number of different values and collect the information of what our metric is depending on what input we give. All right, so what we're going to do is we're going to set up a sweep series. So as a reminder, in order to set this up, what we have to do is we have to create a sweep series object. We're going to do a parameter sweep to try out different immunization percentages and see how it affects our metric. Okay, and so whenever we're setting up a parameter sweep, then what we do is we're going to start with our base system like we had before, and the only thing that we want to change is this 0.1. And we're going to choose a bunch of different values of 0.1 and put those in to this system and collect that information in a sweep series. So in every time when we're going to create a sweep series, we see how it works for one. We make sure that our code works for one value, and then we now choose a bunch of different values. So here's what we do. We create our sweep series. Sweep equals sweep series. And this is giving us an empty container that's going to collect the information as we go along. We're going to write down our list of values that we want to plug in for this 0.1. So we'll define this as immunize underscore array equals linspace from 0 to 1. And we want there to be 11 different choices. So if you recall, what this is telling us is we're getting a list of the numbers 0, 0.1, 0.2, 0.3, up to 1.0, and we needed that the value is 11 because there's 11 numbers starting at 0 going up to 1 by units of 1. And this is going to be our possible immunization percentages. All right, so we've got this array of different values. And then what we're going to do is we're going to put all of this code into one for loop. So for fraction in immunize array, we want to do all of these things. So we have our object here, our array, our immunize array, and we're looking at all the different possibilities of what's in that list. And we're going to put those where we had our 0.1 before. So we're going to put this fraction inside the immunization. And so this is going to feel a lot like exactly what we did before, which is up until this point we have created our system. We have put the fraction of immunization into the system to update, moving some people from susceptible into recovered. And then we've run our simulation with that information. So now, for each time we run this for loop, we are getting a new time frame, or that's keeping track of the number of people susceptible, infected, recovered over time. And now we want to take this information and put it into our sweep series. So this sweep series that's up here, we need to now put this information into it. So instead of taking this our metric that we calculated and putting it as one number, we want to store that in our sweep series. So to store it in our sweep series, we will take this thing, we will put it inside our sweep object. So we do sweep of fraction equals our metric. So this is our sweep object, and we are now putting this fraction as the independent variable, and the dependent variable is our metric that we care about. All right, and then now what we have as we're going through this process, remember we're creating this sweep series, and we're basically getting a chart where for different values of our fraction is 0, 0.0, 0, 0.1, 0, 0.2, up to 1.0, we're getting our metric that we care about. And I guess we already know some of these values. This first one was 47%, the second one was 31%, and so a good thing to do then would be then to plot this sweep series. So then plot the sweep series. All right, so let's go over to Python and see that in action. Here's the Python notebook. Here's this code that we've just been working on. Sweep is equal to sweep series, create our list of values that we care about, get a for loop, and when we run this code and we look at what sweep looks like, we get these numbers. We started off with our 47%, 31%, then 20% vaccination gives us 16%, and we keep going. It looks like we've got some small rounding error since we shouldn't have negative values at all. And then when we plot this, what we get is we get this really nice curve here that's saying that once we start to get past maybe 40% of the population that's been vaccinated, then we're down below 5% of the population that gets sick. And we can see the exact number up here, 3.5%. So this is a pretty steep curve. Once more and more of the population gets immunized, then fewer and fewer people get sick in all. And that's the idea behind herd immunity, in that you get enough people to be vaccinated, then those people are no longer susceptible. They won't become infected, and they can't infect other people. All right, so that's one way that we can use a sweep series to in concert with this SIR model. And in the next video, we'll see another. All right, see you soon.